Hi, Miss Marion here. We are doing Unit 4, Lesson 3. So go back to page 126. Go ahead and read the I can statement. I can add, subtract, multiply, or divide each side of an equation by the same expression to get a new equation with the one solution. And go ahead and give yourself a sentence on that, and also a number. So 1, I don't remember. 2, I kind of remember it. 3, I remember, but don't ask me to teach it to my friend. And then number 4, I can go ahead and teach it to my friend. So go ahead and do your sentence and do your number. So our goals for today is we're going to be able to compare and contrast orally and in writing solution paths to solve an equation in one variable, but by performing the same operations on each side. And we're also going to be able to correlate orally and in writing changes on hanger diagrams with moves that create equivalent equations. So we're going to kind of talk about hangers and then go into equations themselves for today. All right, let's go ahead and turn to page 21. And so here we have figure A, B, C, and D shows the result of simplifying the hanger in figure A by removing equal weights from each side. Let's go ahead and just do number 1. We're going to write the equation, how it goes with each figure. And notice how down on the bottom, this is what you can actually choose from, and then you're going to actually apply it to the different figures. And then you're going to do A, B, C, and D. So go ahead and pause it right now and go ahead and do that, and then come back to me. All right, now since you've done it yourself, let's go ahead and kind of go through some stuff. And I'm going to kind of show you how I like to go ahead and do it. And so I'm going to kind of work at what I know and what I can kind of look at. So I like to look at D first. So D, there's 2 of these triangles and then 1. So which of these equations have 2 of something and then 1? That is this one. So what I'm going to do is I'm going to write it underneath it. And yeah, we'll do it in blue. So let's do 2y equals x. So that equation's gone. Now let's go ahead and look at the other one. I have 3 of something and 1, and then 1 kind of like of that, and then 2. So I have, if we look at this one, I have 3 of the y's and 1, and then 2 of the 1's and 1 of the y's. So that will go there. So let's go ahead and let's write that down. So we're going to have x plus 3y equals 2x plus y. And then I'm going to go ahead and cross that out. And then let's go ahead and let's look at the next one. So these other ones that we have, they're kind of interesting. So I know I have a 4x plus 2y on this side. And then I have 2z plus 4x plus 2y. So do I have a 4 and then a 2 on this side? And then like 2's of these x and then plus 3y. It's just a little different way of doing things. But I believe that those go together also. So I'm going to write that kind of below it. So I'm going to say this one is the 2x plus 3y equals the 4x plus 2y. And then which one is left over? It's that really, really big one. So I'm going to go ahead and start copying everything onto here so we know what we're working with. So A is the 2 of the x plus 3y plus 2z equals 2x plus 4y plus 2z. Oops, sorry, I wrote that wrong. Let's try that one more time. On that side is 2z plus 4x plus 2y. And then B was the 2 parentheses x plus 3y equals 4x plus 2y. And then C was the x plus 3y equals 2x plus y. And the last one was 2y equals x. All right, so number 2, each variable, x, y, and z, represents the weight of one shape. Which goes with which? Go ahead and answer that question. So pause this and answer that question, and then come back to me. All right, so just kind of looking at it, the x is the blue square. Okay, and then let's go ahead and let's do y. Y is the green triangle. And then last one, z is the red circle. Okay. All right, let's go ahead and look at number 3. Explain what was done to each equation to create the next equation. If you get stuck, think about how the hangers have changed. So go ahead and answer that question. So you're going to pause and answer that question and then come back to me. All right, let's go ahead and let's look at this. So going from A to B, what happened there was that we took off 2 circles from both sides. Okay, now let's go ahead and let's figure out what happened from B to C. So going from B to C, so there's only 3 triangles and then 1 triangle. So there's 3 and then there's 3 and then 2. Okay, so this side only has 1 triangle left over and then 3. So we should do 1 triangle and then 3. Okay, and then if you also look at it, there's only 1 square and then 2. So we can go ahead, let's say that we can take off 1 square from each side. So if we keep on doing this with all the different pictures, we notice that the same type and number of objects were removed from both sides to go ahead and make the hanger balanced. And so that's what we're kind of looking at is, okay, what kind of moves are we making to go ahead and keep those hangers balanced? And notice how we kind of do it to both sides. Remember, we have to keep that hanger balanced. All right, let's go ahead and turn to page 22. On page 22, it has Noah and Lynn both solved the equation 14a equals 2 multiplied by a minus 3. Do you agree with either of them and why? So I want you to go ahead and just kind of look through what Noah and Lynn did and see if you agree with them or disagree them. So pause and then come back to me. All right, so let's kind of look at it. Let's see what Noah and Lynn are doing. So Noah, so to go from this step to this step, he went ahead and he distributed the 2, right, to both, okay? And then he went ahead and he got the 2a minus 6, and then going from here to here, notice how there's a 2a here and then 14, but there's no 2a here and then 12. He went ahead and took away 2 a's from both sides. And then got to the 14 equals, and then still that negative 6 stays. Okay, that works. And then how do we get a by himself? Well, he went ahead and he divided by 12 on both sides. And then negative 6 over 12 can reduce down to the negative 1/2. So I do agree what Noah did. I think that's great. All right, so let's go ahead and let's look at Lynn. What did Lynn go ahead and do? So Lynn, there's 14a, 2, and then a minus 3. Notice how down here there's just an a minus 3, and notice how it goes from 14a to 7a. So what did Lynn do? Lynn went ahead and divided by 2 on both sides, just kind of got rid of that number. And then 2 divided by 2 is 1, so it kind of leaves it alone. 14a divided by 2 is 7a, so that's where that 7a came from. And then we just have the a minus 3 left over. So then notice from here, there's an a here, 7a, but there's a 6a, and then no a left over. So Lynn went ahead and subtracted off a, like 1a from both sides, so 1a. That's kind of jumbled. Let's rewrite that a little bit nicer so we can see that. So subtracted off 1a, because how many a's are there? Well, there's 1. So, and then 7a minus 1a is 6a. 1a minus 1a is 0, leaves a negative 3. And then notice how it went from 6a to a, then -3 to 1/2. So Lynn went ahead and divided by 6 on both sides. -6/3 reduces down to -1/2. So these are two different ways of looking at things and seeing them. Both of them did them different way, but they also got the same answer. Personally, I like doing it this way first, distributing it first, and then solving it, because sometimes when I try to get rid of the two at first, for me, it just causes some problems. But both ways go ahead and give the same answer. All right, so let's look at number 2. Elena is asked to solve 15 minus 10x equals 5 multiplied by x plus 9. What do you recommend she does to each side first? Okay, so go ahead and think about that. So pause, answer that question, and then come back to me. All right, so let's kind of look at what Elena could do. So I could either kind of take this 5 and multiply it in, distribute it in, so hippity hoppity distributed property, right? Or I can I can go ahead and I can divide by 5, but the problem is with the dividing by 5, if you do that, that means you have to divide everything by 5. So this is where it kind of, for me, causes some problems when I try to divide by 5 first and then solve it. But either one actually works as far as the first step. All right, go ahead and let's go to number 3. Diego is asked to solve 3x minus 8 equals 4 parentheses x plus 5. Do you recommend that he does to each side first? Go ahead and pause and answer that question and then come back to me. All right, so what can we go ahead and do first? Well, again, I can either go ahead, I can either distribute the 4 through, so 4 times x and then 4 times 5, so get 4x plus 20. I can do that first, or I can divide by 4 on this side, but again, I have to divide everything by 4. But it does not matter which one is first. Personally, I like to go ahead and distribute it in the 4 first and then solve it, but that's just how my brain goes ahead and understands that. So hopefully we can understand different ways of like starting and solving equations. Remember that we have to go ahead and do the same thing on both sides to go ahead and solve. So again, whatever you do to one side of the equation, you have to do it to the other. We always want to go ahead and make our hangers that they are that they're balanced on both sides. So we have to make sure that we do it to both sides. Remember, we're doing hangers is what we're doing. Yes, we're dealing with equations, but we're dealing with hangers, and so you have to make sure that you have to keep both sides that they are going to be balanced. So go ahead and go back to page 126. Go ahead and give yourself a sentence about today that we can add and subtract, multiply and divide each side of an equation by the same expression to get the same equation with one solution. So go ahead and do that. And then come back, and we're actually going to be talking about what the homework's going to be. There's going to be 2 things for you to go ahead and do. So in Canvas, there's actually a couple of things, and it's set up that you have to go ahead and you have to do it in order. So you want to go ahead and do the solving equations hanger method. It helps us go ahead and solve hangers. So you'll have a hanger, and you're going to go ahead and figure out what you can take off from both sides of the hanger to keep them balanced. And then from there, they're going to talk about matching equation moves. So we're going to look at equations. We're going to have one equation, like a sentence, and underneath it, and you're going to kind of see what did they do to go ahead and go from the first step to the second step. These 2 things have to be done first before you can go ahead and do your practice problems. And it's actually set up that way. You do have to get 8 out of 10, so you have to get 80% on it before you can even move on from the first one to the second one. There are unlimited attempts on these, so make sure you go through it, make sure you understand it. If you have any questions, go ahead and make sure you email me or ask me, and we can kind of go from there. So have a good day, and hopefully you understand everything. Thank you.